Welcome to Bürkert Bytes. My name is Chris Hoey. Digitisation is drastically transforming the automation world, as well as creating a lot of opportunity. In this series of videos, we take you through the best practice for digital connectivity in process automation. We hope you enjoy. Welcome to our digital connectivity video on IOLink and connecting IOLink in the field. IOLink has been widely accepted in recent times simply because it's very capable and yet very simple network to understand and to deploy in the field. It generally consists of blocks that are talking onto a main network like Profinet in this instance here, or on this side we have Ethernet IP. It could also be Profibus, there could be CC-Link, it could be other networks. So it's a sub-network where we actually link these field networks to individual devices. But not like an I/O block where they just link to simple devices. These are smart ports where they can actually link to digital devices. So to give you an example, this is a block of 8 for a standard industrial application, and this is a similar one but used in a hygienic application, so therefore in stainless steel. So a couple of the options that you can do with any of these ports on here, firstly you have your Ethernet coming in and out necessarily. So in other words, as an example here, which means it can go onto a redundant ring topology, which makes it easy to put into the field. You have an additional power supply that can be brought into the modules, so therefore you've got enough power locally to be able to power whatever devices you've got installed. And then you've got in these instances, both of these examples have 8 IOLink ports. These ports are also quite functionally capable in the fact that they can be set up as just a digital output. In other words, this first port could be used and is connected here just to a solenoid valve in 24 volts DC. So in other words, it's operating just as a traditional I/O block. However, the ports can also talk digital communications to the devices in the field. So as an example, a similar IOLink port in this instance is talking to a block that has 4 valves in there controlling actuators in the field. Alternatively, if we come over here, we see we have a block talking to 8 valves in the field. So these valves are all controlled via the IOLink block. And of course, on that same type of network port, in this example here, we have up to 24 valves connected on a single IOLink port. Now the nice thing is this IOLink doesn't just control the valves, so we're not just saving wiring, but all of the asset management and diagnostic information of this device is also passed up to the IOLink block. So in other words, you've got a complete footprint of everything that's in that device is being communicated up into the IOLink head. So, and that gives you a lot of functionality and a lot of features. So as I mentioned, you can control all of these different devices, whether they be modulating valves, on-off valves, or control valves. To give you an example, I will just operate this 8691 head, which is on a modulating valve here from the Ethernet panel, Ethernet IP panel, and I can operate and open and close that. So whilst I can open and close that, this is also hot swap capable. So in other words, let's just say a forklift backs into this head and smashes it. So you disconnect the network with a simple M12, which is the entire wiring in IOLink. There is no cables to connect, etc. So that's now, we replace that head, and when we put a new one in, it will automatically reconfigure and make itself fully operational again. So what I'm going to do now is I'm going to pass over to Nelson, who's going to take you through the configuration of one of our I/O blocks going into IOLink.
Thanks, Chris. We're going to take a look at the Bürkert 8653 IOLink remote valve manifold, how that's integrated into a Profinet master. We first need to download the IOLink description files. You can find these on the Bürkert website under device description files. Once downloaded, we need to configure them into the IOLink master. In this case, we're using a Profinet IOLink master from Baloof. ports are configured as port number 1, and then what we do in TIA Portal is import that block as an element in the Profinet system. We go into that block and we assign a 3232 byte 1 to the first port. Once that's assigned, we then create a tag in our tag table for our first valve with an address of Q0.0. We then put that into the watch table, and for online we can actually modify that value. So at the moment the value is false or negative, put a value of 1 or true. We write that value and the valve turns on. Back to you, Chris.
Thanks, Nelson. So as you can see, it's quite easy to integrate and there's quite a lot of information available in any IOLink network. So as well as valves and the modulating control and we also can do sensors, and we're showing examples here of a pressure sensor and also a temperature sensor, which I can wrap my hands around and you'll see in the main system that the temperature is increasing. Okay, so what products does Bürkert have available? Bürkert has quite a range of products available, as you can see here. On-off valves, modulating valves, rotary valves of both on-off and modulating as well. The complete blocks, IP67 blocks for the field, DIN rail blocks for inside panels, control tops to go on hygienic valves, and a lot more. As well as all the knowledge and accessories to put it all together into complete systems. And there you have it. That's our overview to IOLink. I hope you enjoyed this Bürkert Byte video. There's a number in the series. I hope you take the opportunity to watch them all. And if you do have an application, our local engineering team is here to support you. Thanks.